Substance. Stories about the stuff that shapes our world.
When people feel it for the first time, they imagine themselves living in the world of the future. And when they touch the material, they're like, there is a future in which I can have this experience. That's luxury.
Substance. When you think about fungus, luxury probably isn't the first thing that pops into your head. Instead, you might think of the itchy gunk that can grow between your toes. Or fuzzy green mold creeping over, oh man, I was going to eat that grapefruit for breakfast. At best, you might think of mushrooms budding from a rotting tree stump in the forest. Maybe they're edible. Best not to find out. 10 to 1, if you want a word to describe fungus, it won't be luxurious. Most people pick something closer to gross. But here's what artist-scientist Phil Ross has to say about that.
Not all snakes are bad. There's a lot of mushrooms. You probably only know 12 or 20 at most, and there might be millions of them.
Technically, mushrooms are the so-called fruiting body of some kinds of fungus, the part that grows so the fungus can reproduce. There are also fungi that are made of only one cell, like yeast, and many fungi transition through many different forms during their life cycle. But that luxurious material Phil referred to in the beginning, it's made of another part of the fungus called the mycelium. It's a long network of nearly invisible fibers that you don't often see because it's in the soil or inside the wood of that rotting stump, consuming and transforming it. Back when Phil was a chef and an artist, he figured out that he could control how those fibers grow to mold them into new materials with incredible properties. Eventually, that led him and his collaborators to develop a fabric with the look, feel, and strength of leather, made not of animal hide, but of fungus. I'm Joe Hanson, and this is Substance, a podcast about the discoveries and innovations in chemistry and beyond, helping us build a sustainable society for the future. In short, we tell stories about stuff that shapes our world. In this episode, we'll learn how fungi have become a breakout sustainable technology, and Phil will share the story of his own journey of discovery.
It's a consequence of just my weirdness and need for stimulation and change myself. So training in the arts, working as a chef, becoming a professional artist, professor, into startup, and then industrialist, and now genomics research. It's not an obvious trajectory. You have to be open to giving up the idea of failure or success in a specific way, because it is just a process of becoming.
What Phil said earlier about the number of different fungi is true. Though mycologists, the scientists who study fungi, have only described more than 600,000 species, most of them agree that there are millions more unknown species.
It is a new branch, a kingdom, a queendom, similar to animals, plants, bacteria. It is now recognized as its very own branch of the tree of life. And this only really came into being in the mid-1970s. So there's only been 2 generations or so of humans on Earth who have experienced fungi, mushrooms in their own right. And they're kind of phenomenal beings, because the best thing they do is they like to eat dead stuff. They eat garbage at room temperature. The sun shines, the plants grow, a lot of built up lignin and cellulose every goddamn day. Whether you mean to or not, the earth deposits its own, just leaves and branches and everything else. It just a lot of carbon being brought out of the sky by sunlight, and the mushrooms eat it. They're the primary ones that are breaking that down in one form or another. They assemble through disassembly. They take things apart to put other things back together. That's just what they do. They create scaffolds and polymers and really interesting things built out of those polymers, really complex polymers and macrostructures. And again, out of chitin, the hardest known organic polymer on the earth. So they know how to weave it together at the micron level. So they're just doing it for their own purposes, man. So imagine if you could focus that
The incredible and diverse capabilities of this group of organisms are transforming the way that biologists think about our relationship with nature. Fungi are already appearing in fabrics like the one Phil developed, as well as in materials used for packaging and even construction. Fungi have even become living factories for vitamins, antibiotics, and other medicines, as well as dyes. Humble fungi could be a key ingredient for a sustainable future for humans. And biologists are really just starting to understand how much they can do.
Imagine when we can get under the hood, they can assemble nanoparticles out of metal in solution at room temperature by the proteins that they exude naturally. So many of the things that we're doing now, they're doing it all the time anyway. They're going to be very helpful in bringing us into the future that a lot of us probably want and imagine would be good for a lot of living things.
Decades ago, Phil was a chef, interested in mushrooms as ingredients for the dishes that he created. Then later as an artist, and now as a biotechnology pioneer. And it all started because he was fascinated by something that others find pretty gross.
I wanted to understand gross things. Like, I wanted to transcend the emotions one feels around a certain aesthetic category as a way to not make judgment about how to understand the world. And so I was looking at that for years and making drawings of that and studying it, again, just to like looking at it as nature and not as gross and understanding why it was doing that. Combining that with realizing when I started to grow them, I was like, oh, okay, that knowledge can be brought to bear upon a medium.
To an artist like Phil, the idea that he could grow a sculpture was a revelation. He began to craft sculptures that grew and changed depending on the conditions he provided for them. Then Phil began to wonder how these materials he grew might change the built world. An exhibition of his work at the Museum of Modern Art in New York presented architectural elements like archways and asked visitors to consider a world in which the bricks and mortar in our cities were not made, but grown. It wasn't their structural properties that made Phil first fall in love with fungi. He discovered their versatility decades earlier through his love of food while working just outside of New York City, where he grew up.
This was a little past Bear Mountain into what's called Clinton County in upstate New York, along a little bit inland from the Hudson River. And this has always been the kind of escapist fantasy zone for New York City, where for many, many hundreds of years, the population has imagined this as something other than urban life. At the time that I was there, it was like a kind of a hippie sleepaway camp. And I was working at this camp doing cooking. One of the other chefs was like, hey, do you want to go out mushroom hunting into the lush backwoods right outside of the kitchen door there? And so he took me out and, within a couple of hours in this basket, we had, I'd say, at least a dozen different edible mushrooms that I had never experienced before, or if I had seen them, it was just like yet another mushroom. And we just spent the afternoon after that frying up each one very simply and just kind of appreciating the flavor and the texture and discussing it. They have so many different flavors. They can taste like a sweet maple syrup cookie. They can taste like shrimp, almonds, chicken, beef, vinegar, all sorts of different, again, like animal meats, but also into strange nut flavors and into all sorts of different textures like crab meat. And, it was like right outside the back door. So it kind of felt like a huge invitation to adventure, in a lot of ways for me.
Substance.
In 1988, Phil moved to San Francisco to pursue an art degree. He was still working as a chef and doing hospice aid for ACT UP, an AIDS advocacy group. And through that work, he became involved with people who were experts in growing fungi for culinary and medicinal purposes.
The San Francisco Mycological Society, this is a local mushroom interest group that meets once a month, and they had back then what they called a cultivation committee, people who were interested in growing mushrooms. And it was done in this person's kitchen who is an accomplished mushroom grower. It was very familiar and a little strange. I had done pastry cooking, so I understood that this is like pastry X, or something like that. It's like where measurement, timing, really, you have to have better control systems in place and standards to execute it to a given level. And this is like an extension of that. So I recognized it as a mutation of the kitchen. And I was also had done fermentation, like, making beer or bread or other fermentation processes. So to think about fermentation of wood through, it was cooking. It really was. And in fact, that's what mushroom growers call it, is a cook.
Humans have been using fermentation for over 13,000 years. Foods prepared via fermentation by organisms like bacteria and fungi appear in every culture on Earth. No pun intended. Okay, maybe the pun was intended because, a culture is also a preparation of microorganisms. No? Okay, never mind. The point is, cultured organisms like yeast, a kind of fungus, transform hops and wheat into beer and water and flour into bread. The fungi Phil and the San Francisco Mycological Society grew. They fermented wood and other plant-based matter, converting them into a squishy substance that would eventually sprout edible mushrooms. But Phil soon realized that mushrooms weren't the most amazing thing that he was producing.
We got our materials from a pet supply store, so like ground up corn cobs or some hay stalks or, the center of a plant, used as animal bedding, available everywhere, supermarkets. It was a lot like cooking. And then we put these things in these little containers that you would store food in with a little bit of this biological mother culture or starter. And then, this like loose mash or substance, after about a week, aggregated, it solidified, it took on form. This was a biological process that was solidifying this aggregate into a solid. The moment was like, holy crap, I think that was like, it took on the shape of this aggregate of the food container that it was placed within and felt a lot like an expanded polystyrene or sort of a mushy, wet, living version of that. So I was a student of sculpture and I was like, it was immediately apparent this is like a way to make substance in a different way and very different from the chemical methods used in creating polymers and things like that.
That realization catalyzed Phil's art career, inspiring him to produce those sculptures that landed in the Museum of Modern Art and other galleries around the world. At the same time, he began a collaboration with his longtime artistic and eventual business partner, Sophia Wang. They began to wonder how the materials they created might replace other materials that are made less sustainably. After years of experimentation, they went on to found MycoWorks, a company that produces leather-like textiles made entirely from fungi.
We were doing material research for a good 5 to 7 years, even before forming MycoWorks, as we were figuring out what that meant to be. Sophia's just, she's also a genius and very creative, amazing intellectual person. When we were starting up MycoWorks, is like, I was a working artist, she was a working dancer, and we were supporting our weird biotech hobby with our arts professional like money. I think we were aware of just like how strange that was. We weren't trying to be anything. I think it just emerged out of a lot of the relationships that we'd built over the prior 20 years living in the Bay Area, doing kind of workshops and skill shares and DIY work. And I had a lot of relationships with the scientists that we ultimately worked with. And, they were interested in the things that I was doing. I would come to them, again, like just as like a naive fool outsider. I would invite myself into other people's open office hours. If the door was open, I would come in. Wherever that was, people arrived. A lot of people, they heard about it, and then they volunteered themselves. From the Stanford Research Institute, met some engineers there from, again, like Cal Poly, other engineers in Berkeley, also PhD students were like, we want to help measure this thing or start to figure out, they knew those engineering processes. I had no idea how to do material validations for composites. I had to learn all that from these people who taught me, who showed up and were like, hey, I want to help you do this. And they were blown away by the results as well. So there's no convincing necessary. And I think that's movement building, like it's self-evident.
Like Phil and Sophia's journey into the world of fungi-based materials, the founding of MycoWorks didn't follow a straight trajectory.
turning into a business, like that was definitely a big transition, but it was also just in response to the problems people were bringing to us. The material came first as a replacement for a silicone expansion foam, similar to the types that are used in like yoga mats or other things like that. And California was coming up and other places with much more restrictive safety measures around production, utility, et cetera. So it came more from car companies that were seeking out this kind of silicone replacement. And we're like, okay, let's see what we can do. We were working in a sub-basement, again, kitchen, not even kitchen, like duct tape, plastic, gaffer's tape, whatever you call it, electrical tape, and plastic sheets. So Sophie and I, being trained artists, communicators, etc., we were media savvy and had to do a lot of our own self-promotion and works as independent artists. And so we quickly adopted all of these tools for advancing our own professional careers or information about our events and things like that, and knew how to work with media who had a global reach and seem a lot larger than two people in a basement with plastic wrap. We made this pretty thick, kind of substance, very thick, pure mycelium mat out of it. But they're like, yep, we could do it. And we're producing this material with companies coming to us and saying hey, can you make this? And we're like, yep, we can make it. We're like, oh, they're like, great. Okay. How do we get to this price point? And we're like, nope, not even going there. We can't do that. No way. Just to scale up production to what there was no way to imagine the pathway to scaling. And 12 years ago, 15 years ago, we were we couldn't figure it out, that problem. Couldn't rectify that issue. So we just shelved it, and it sat there, that knowledge, the methodology. And then when I think 3 or 4 different luxury leather brands came to us within a very short 1 quarter by measure, Fortune 500 companies were like, hey, cold calling and saying hey, do you have anything like a luxury leather analog? And we were like, we looked upstream. We were like, something's going on in the world. Again, it was me and Sophia in the basement and receiving these calls. And we were like, what is happening? And it was more of a supply chain issue than any desire coming from consumers for a new kind of leather. So it was more from the producers of leather who, prior to Corona even, were having huge supply chain complications and price variabilities for luxury products. And we just were receiving a lot of incoming requests to create a luxury textile analog, and ours fit right place, right time for a very big pain point. We very quickly figured out what leather is or something, and we didn't know anything about leather as a material, but we had this material and we're like, what if we made this thinner and figure out a different configuration of this material for what these people want? It's kind of the same thing, like a thin expanded silicone foam. But that's pretty close to leather. And from our point of view, we chose the simplest path towards how you do that.
Following that path, MycoWorks developed a replacement for leather in luxury products. Handbags by Hermès, furniture by Ligné Rosé, and Studio Tui, accent paneling in Cadillacs. They called their material reishi, after the Japanese name for the Ganoderma, which is the genus of fungi it's grown from.
The product it's like when you touch it, it is amazing. It's like magic. I don't know. I'm still blown away by it. You can't believe it's real. It's sort of like the uncanny valley of things. It opens a weird door of reality, of just imagination. People project themselves into the future as a result of that. It's magic. I don't know how else to describe it.
Substance.
Today, MycoWorks has transitioned away from producing mycelium to figuring out how to process it so that it's stronger, more flexible, and more versatile than the animal leather it replaces. 4 years ago, Phil became a co-founder of the nonprofit Open Fung as a way to push fungi-based technologies even farther into the future.
That we understand is important is the role of artists and designers in creating the meanings and values and interpretations of how to integrate with mushroom as a thing that's going to be with us for a long time. So that's what I see kind of purpose and focus of Open Fung. Regardless of any of the specific programs that we're doing, that's our mission focus.
Sustainability is the core value behind the organization's forward-thinking vision, which they describe as a future where humans engage with fungi so life and the planet may flourish. OpenFung is working to scale industrial biotechnology based in fungi, which is also known as white biotechnology, as a way to produce valuable materials with fewer resources. That includes stuff made from fungi, textiles like reishi, and building materials like the ones Phil exhibited at the Museum of Modern Art, and also the molecules and substances made by fungi, which can themselves be used for medicines and new materials. For Phil, there's no limit.
OpenFung is working to develop fungi as a global utility for growing the things that are needed in the places where they are needed from materials that are right around there. But to share this information globally as a way to start to accelerate that by a lot of people contributing to this. So it's not to make something that would be used globally, but to also show how you can do it locally. We're doing a survey of a Ganoderma, a type of mushroom that is really good for growing materials, chemicals, helping to grow medicines, all this interesting stuff that's right here in California. We're working to make a California Ganoderma that is situated for the location that it's in and to make it much more open as a resource that can be transferred to Ganodermas that are growing, say, in Chile or Canada or Germany or anywhere else in the world where it's already environmentally acclimated towards. There's just a lot that still needs to be done. And there are very few standards and measures or centralized resources or access to things. Why don't we have nice things yet? And it's like, because there's a huge amount of bottlenecks all over the place. We can do this by putting some pressure on these different elements of the collage to make some of these pieces come together a bit better. And yeast went through this 100 years ago and other microorganisms, and now it's available for a growing, small but growing cadre of multicellular organisms that are going to start to do, the next generation of platform utilities for biology.
Birgit Hoff's work shows just how that future might play out. Hoff is a biologist at BASF. Her work with fungi shows the promise of this emerging field of white biotechnology, which supports the chemical industry as it transitions away from fossil raw materials to renewables. Fungi can replace chemical processes that previously required crude oil or natural gas feedstocks. Alongside related technology from bacteria and other microorganisms, fungal biotechnology is critical for advancing BASF on the path towards climate-neutral chemistry.
Fungi are really powerful organisms which can produce a huge variety of molecules which are really important for our daily life. I think one of the biggest misconceptions is that fungi are simply harmful. But I think that's only just one side of the story. In reality, fungi are incredible, diverse and powerful organisms. They play a really essential role in our ecosystem as decomposers, and they can interact with plants as symbiotics, and they can produce valuable compounds like antibiotics. I think many people don't know that without fungi, we wouldn't have penicillin today or even some of our favorite foods like cheese or soy sauce. Yeah, they are just small biofactories, I would say.
At the root of these biofactories is fermentation, a fungal specialty. As Hoff just pointed out, that same process humans have used to create foods for thousands of years, not just cheese and soy sauce, but bread, pickles, sauerkraut, kombucha, and more. It powered the materials Phil created for MycoWorks and the new science he's trying to achieve with OpenFung. In the same way, fermentation also powers Hoff's work at BASF. She's putting the tiny organisms to work on a large scale, feeding them organic raw materials such as sugar and vegetable oils, and engineering the fungi so they metabolize them into sustainable products.
Fermentation means cultivation of organisms under really controlled conditions. And controlled conditions means that you can control parameters like pH, oxygen, temperature, and also the cultivation medium.
Even before Hoff arrived at BASF, fermentation was an essential tool for producing an essential vitamin, vitamin B2, also known as riboflavin.
What's absolutely clear is that today no vitamin B2 is produced via chemical synthesis. All vitamin B2 we have on the global market is produced via fermentation, since it is more cost effective and it is more sustainable.
Our bodies need vitamin B2 for our metabolism and to repair damaged tissue. A person with vitamin B2 deficiency might experience headaches, fatigue, dry, cracked lips, or skin rashes. In many countries, the vitamin is added to cereals and bread, as well as to animal feeds to ensure that people and animals have enough in their diet.
Vitamin B2 was produced for decades by chemical synthesis. It was a multi-step process with low yields, which needs several raw materials, and the use of a fungal production host gives clear advantages. So with a fungal production host, you have a system which can naturally metabolize or produce vitamin B2 in its own metabolism. Then you have a one-step fermentation process, and at the end, you generate vitamin B2. And the fermentation also takes place under mild conditions. So it's a water-based system. It is at room temperature and under atmospheric pressure. And so it led to an significantly improved eco-efficiency. And for vitamin B2, it was analyzed really in detail. And the switch to fermentation has led to lower raw material consumption. It has led to 25% less energy use and even to a more than 30% reduction in the global warming potentials.
Pushing that process to be as sustainable as possible inspires Hoff's work.
My job is to optimize this fungi on a molecular biology level to enhance their productivity and to tailor them that they produce the kind of molecules we want to have. One of my main responsibilities is to optimize our fungal production host, which is used to produce vitamin B2.
That fungal production host, the organism that actually makes the vitamin, is a fungus called Ashbia gossypi. It's on a completely different branch of the fungal tree of life from the Ganodermis that Phil works with.
Not the kind of fungi you found in the forest, but it's more the ones you know as moths. This kind of fungus is a natural overproducer of vitamin B2. That means the fungus can produce vitamin B2 naturally by its metabolism, but only in small amounts. And our job is now to further improve this vitamin B2 production so that we can produce at the end vitamin B2 in large scale and in ton scales.
In 2021, Hoff's work with Ashbia won her the Innovation Prize from the German Society for Microbiology. Today, BASF uses the fungi grown and improved in Hoff's lab to produce vitamin B2 on the scale of tons at a time in huge tanks that hold the fermentation reaction.
Can you imagine how exciting it is to see the production organism you have developed in lab to use it the first time in a huge production facility? That's really great. It's really impressive to see them. If you see such a main fermenter, for example, for the vitamin B2 plant, it's really fascinating to see that an organism which you handle in your lab in really small scale, that it is able to grow in this really huge. That's really a great moment, I would say, to see that something you have developed in the lab is scaled up, is commercialized, and then is used globally for production.
To create that organism, Hoff's research relied on the cutting edge of modern biotechnology.
We have really powerful toolboxes from classical microbiology to the modern molecular biology. We can really look deep into the fungal metabolism and can find out which kind of pathways are involved in producing vitamin B2. We can really precisely modify such pathways. We can enhance pathways, we can silence pathways, so that this fungus, it convert really efficiently the raw material, in this case vegetable oil, to the final product, vitamin B2. We normally use more highly advanced modern techniques. So using technologies such as DNA editing, we can precisely modify the genetic blueprint of a fungus. We can enhance or silence specific metabolic pathways to boost the productivity and also to reduce unwanted side products. We can sequence our genomes, that we know how genes are expressed and which kind of metabolic routes are active. And we have, of course, some digital tools in place, for example, metabolic modeling tools, which helps us to simulate a little bit what kind of changes have impact on productivity of a fungus and which not. So this helps us to design experiments and to speed up optimization.
Some of those techniques Birgit mentioned have only been around for about a decade. Her work on vitamin B2 is just an early example of what many in the industry think will be a wave of new biotechnology based on fungi.
Studies said that the global wide biotechnology market is projected to increase with an annual growth rate of about 10%. And that's faster than the classical chemical market, I would say. I think biotechnology can really not only support the chemical industry, but also complement and strengthen the chemical industry in the future.
Substance.
They're currently being researched to grow habitats on Mars, the moon, and into outer space, as well as very intimate interfaces between our human bodies and weird organic electronic instruments. They're capable of synthesizing almost any type of molecule from what we call garbage, which could even be the wrapping from your potato chip bag, which could be converted into a potential cancer drug or other thing that your body might need, like at the location where it exists, rather than manufactured far away and made exactly for you in the way that's required for you for that medicine. So I think those futures are really interesting, again, beyond the sort of more obvious of textiles and building materials and other things that you imagine them for now. They can do all this other stuff at that molecular scale that we want. Again, the desire that we impress upon it, they can deliver it. So it's sort of a remarkable relationship.
We've only even recognized fungi as fungi for fewer than 100 years. But we've used them to shape our societies since the very beginning of civilization as we know it. Where would humans be without bread or cheese or penicillin? Still, we've only recently scratched the surface of what fungi are truly capable of, the wealth of discovery that might be mined from fungi just doing what fungi do, growing, consuming, and creating. Sure, some of them might look a bit gross while doing it, but if we can look beyond that, we might realize that underfoot, under our noses, is a sustainable 21st century technology poised to carry us into the 22nd. Next up on Substance, arguably the most important molecule in the history of humanity. It makes Earth, Earth. We and everything else can't live without it, literally. That's right, we'll be talking about water. Stay tuned. This has been Substance, stories about the stuff that shapes our world. Substance is a podcast by BASF, produced by Territory Agency, in collaboration with WakeWord and me, Joe Hanson. Research and scripting by Danielle Sedbrook, Claudia Doyle, Hardy Roda, and Joe Hanson.